the temperature T of a piece of metal changes over time T as it is rapidly heated and then cooled again. It is modeled by the equation T, the capital T equals minus 5 small t whole square plus 40t minus 35. So first we have to plot the graph of the equation on the grid, and then we have to find at what time the metal reaches its highest temperature, and using your graph solve the equation minus 5t squared plus 40t minus 35 equals 20. So for this question, the starting point is to draw the graph, and to draw the graph we have to find the points where the this is going to be the equation of this is an equation of a curve, so the graph is a curve and it is going to be an inverted curve, so it's going to be something like an N-shaped, because the coefficient of t square is negative. So that's going to be the shape of the curve, and we need to find where it cuts the x-axis, or in this case the t-axis or the time axis. So and also if it cuts the temperature axis or the y-axis. So we will do that, and what I do is when t equals 0, so when time equals 0, the temperature is minus 35. So that's where it would cut the temperature axis, and then when the temperature is 0, we need to find um, the time, and so we equate it to 0, and we get minus 5 taken outside the bracket, so t squared minus 8t plus 7, and that equals 0, and minus 5 can't be 0, therefore t squared minus 8t plus 7 is 0, and we go and factorize it, so we get t squared minus 8t can be written as 7t minus 7t minus t plus 7 equals 0, and taking t common, so t within bracket t minus 7, so that's for this bit, and then minus 1 times t minus 7 equals 0. So when you multiply you would get minus t plus 7, so that equals 0. So therefore the solutions are t equals 1 and t equals 7, and we will plot them on the graph. We mark the points on the graph 1 and 7. So now we have to draw the curve. We need to know another thing in the curve is how far or how high the curve will be. It's inverted, but we need to know how high it is. So we need to find, in this case, because there are two solutions, we need to find the vertex. So what we will do is we will find the symmetry. It is symmetrical, so we need to find the midpoint, and the midpoint is 4. So because the midpoint is 4, so if you I draw the line from 4 and then I draw the curve, and though it doesn't look very symmetrical, I'm sorry about that, it's my drawing with the tool, the curve tool, that's really not accurate, but however it gives a sense of what the curve should look like, and it sort of will get us to the quite close to the correct answer. So well, that's the curve, and the point of symmetry is 4, 0. So I think part A is done, because that's all we have to do in part A. We have to plot the graph, and part B, we are asked at what time did the metal reach its highest temperature. So obviously it would reach its highest temperature at t equals 4, time t equals 4, because that's the vertex where so that's t equals 4, and then that done, we move on to part C, and here we have to do is we have to find a solution for that equation. So minus 5t squared plus 40t minus 35 equals 20. So you see this whole thing, this bit is t. So if I call this y, then all I have to do is draw a line for not y equals 0, y equals 20, and find the corresponding values on the x-axis. So that's what I did. So that's the equation they've given us, and if we take that equals y, and that's the curve, you see that's the curve, that is the equation of the curve, the y, and what we do is y equals 20. So if I were to draw y equals 20 and read out the points from the graph where where it's the x coordinates would be, and I would get t equals 2, and the other one I'm getting t equals 6.3, somewhere around there. Now the correct answer that they have said is t equals 1.8 and t equals 6.2. So I'm not wrong. Plus minus 0.2 is allowed error. So I'm within the error margin, but so you can see how you would draw the graph and how to get to the answer. So I think we can say that this question has now been completely answered completely.